Thank you very much. So the way it works is that I'm going to give an overview, relatively short presentation, and then after me you are going to hear the details. So the project is relatively large project, 3.5 years the duration, and the key is that it's a community-based project. Numerous individuals are involved, and I'm going to show you all the names. The names that you are seeing here are key chair, co-chair of various working groups that you will see. So I'll go over the project. Okay, I'll do it. Okay, before I start, I want to acknowledge obviously CEA, California Earthquake Authority, very important agency in the state of California. They are funding this project. Besides funding, which is obviously very important, we have had extremely professional relationship with the management and staff of CEA. Janelle, Shana, Badi, really we enjoyed. It is so easy when on the other side of the table you have really professional people. Everything works very well. We appreciate their support and encouragement. Then there are two different review panels that I'm going to elaborate a little bit. One review panel on behalf of CEA, one review panel on our behalf of the project, and we benefited from both panels. I'm going to elaborate a little bit more. There are lots of people, they work on this project. Numerous people. This is the strength of our community. Large projects, many people involved, students, postdoctoral fellows, researchers, practitioners, and at the end we stitch all the pieces together. It's really like a large puzzle, that pieces of puzzle should go together at the end. So these are the people who are involved. On top, obviously CEA, funding agency. Right-hand side, you see John Ostres, Tom Heaton, Kit Porter. There are reviewers on behalf of CEA. We have had numerous interactions with them. We received very good feedback from them. Then in the heart of this thing, you see so-called leadership, you need a small group, because any large project crisis happens, suddenly the cost overrun for testing or analysis is behind, a lot of things that can go wrong. So the leadership group, immediately they get together to resolve anything and plan for the next step. Right-hand side of that, you see Grace. Grace has a very important role in this project, large project. You need someone to make sure the deliverable of working group 1 to go to 2, 2 to 4, and so on. Grace really has been a key in the project. Left-hand side, you see our own review panel, which includes Hovag, Blaney, Scott and Hooper, and Steve, which I'm going to have one slide after that. Then there are multiple working groups, many individuals involved in that one, and on top of them, really there are graduate students and even undergraduate students. Having said that, you see, Steve May, I have one slide. Someone told me, you want to include his name? I said, absolutely, I really like to include him. We started the brainstorming, even RFP, at the RFP level. We wrote proposal together. He started the project. Now we miss him a lot with his vision, leadership, and ideas. I still miss him. I used to call him every day. And I said, Steve, what about this? And then he used to give me 500 different ideas. We miss him a lot. So the project, the objective of the project really is that, so suppose you have a cripple wall system, which is a deficient system, and you retrofit that. The ultimate goal, which is outside of our scope, is that how much discount you can get in your earthquake premium. That is not really our job. CEA, as a financial institution, they are going to decide how much discount they give you. However, from research point of view, really we want to see how much in terms of fragility you get the benefit. We pass it to CEA. CEA is going to decide about exact premium discount. So the project has obviously For the first time, there were other projects in our community, but for the first time, we did experimental work, lots of experimental work, which I'm going to elaborate, and lots of simulations. Obviously, experiment, you cannot do everything, and you need simulations. So, and the strength of our project, like any large project that we have been doing in the last 20 years, is that the combination of academics as well as practitioners. This is not an abstract idea that you write a paper and you win Nobel Prize, which is a good thing to do, but this is not the thing. This is really applied research. We do something for the specific purpose. We started October 17, 2016. We are going to finish it April 17, 2020, literally 2-3 months from now. We are not planning to get no cost extension. We are really shooting to finish it. There are 7 task working groups with lots of people involved in these things. These are the working groups. So we started early on from the literature review. That is already obviously done. Then there are lots of types of buildings and with different configuration, index buildings, that's already done, then ground motion for the simulation, and then loading protocol for experimental work, then experimental investigation, which I'm going to show you a couple of slides, and lots of analytical work. I'm going to show you a couple of slides, but will follow. And then obviously the whole thing comes together to do fragility functions, and then reporting obviously is very important. I'm going to show you a couple of slides on these 2 tasks. After me, you are going to hear more on the details of the analytical work as well as fragility as well as the reporting. So experimental work. We did 2 different campuses of the University of California. At UC San Diego, they did numerous small-scale testing. Professor Tara Hutchinson and her PhD student, Brandon Schiller, they were working really hard to do all the experimental work at San Diego. At Berkeley, large component testing, and Kelly Coben and her postdoc, Wahid Mahdaviar, they were doing the experimental work. At San Diego, overall, they did 28 specimen tests, very different size with different configuration, with different boundary conditions, which I'm not going to go over that. There was a poster, I think, last night, and also last year, Kelly went through the details of that. Lots of variation. Star code, non-star code, different siding, different sheeting, and so on. They organized it and they are done. So this is one example. There are hundreds of these things, hysteretic loop, that engineers, they love to see that. So the blue is unretrofitted, existing, and the red retrofitted. And you see, it's unbelievably more strength and the ductility of the retrofit specimen. So there are lots of things like that. There will be 2 reports from the UC San Diego. They are drafted, and they will be published as peer reports. Then at UC Berkeley, Kelly was in charge of experimental work, Kelly Coben, and they did a larger scaling testing. This is one photo, and just to get a feeling about the size of these things, I have these things, and the fellow who is behind the window is Dave Walsh, who is going to talk after me about the simulations. This is another example. This is large component testing at UC Berkeley. The retrofitted versus existing, and as you see, a lot more strength and ductility of retrofitted. Computer simulations, obviously, you do experimental work to do validation and to understand really some details that possibly simulation cannot capture, and then you rely on simulations. Simulations were carried out with the leadership of Greg Derline and very competent postdoctoral fellow Dave Walsh, who is going to talk after me. They did unbelievably important and high-level simulations. So among various variations they did then hundreds of ground motion, 40 ground motions at different return periods, and then they ran OpenSeas, lots of analysis, and then they took it all the way to the fragility. So they sent me these things. Bottom line, 3.8 million runs they did. And then the various details that after me, Dave is going to talk about it, and they took it all the way. So this is one example. The curves that you see, this is the loss versus the intensity measure. The top loss, two curves are for existing curve. When you retrofit, obviously it drops drastically. So that is very good news. Summary, the project is progressing very well. We are going to finish it on April 17, 2020. Multiple peer reports will be published by that time. On top of all these multiple peer reports in the next few months, we are going to have two other reports. One summary technical report that is going to give reference to multiple peer reports, and another very challenging but important so-called non-technical report, a report for non-researchers that Cheryl is going to talk about. That is very important for community. A website will be created at PEER with all the documentations, background data, and so on. We don't want to lose this after the project, and will be communicated. Now, if you ask me, I'm principal investigator of a project, 3.5 years, you ask me, what summarize it in 4 words? Really, if I want to do that, I was thinking last night, what should I say? I think the best thing is that retrofit is really effective. It works, experimental work, analytical work, it helps. I have a relative, they have with a similar house in Concord right here, and I'm telling him, retrofit, it works, really it works. Appreciate that, thank you very much.